This is section 253. We're going to take a look at a system of nonlinear equations. We're going to solve a system of nonlinear equations with linear equations. So as a recap, remember, there are two ways to solve a system of equations algebraically. It's the substitution method, where you plug in a variable and what it equals into the other equation, or the elimination method, where you add the equations together to eliminate a variable. The most common way that you're probably going to see for a system of nonlinear equations is probably the substitution method, although there are some exceptions in which the elimination method is warranted. So let's look at this. We both notice that y is by itself, y equals x squared, and y equals 8 minus x squared. Well, that means I could substitute what y equals in one equation into the other equation. And so if I do that, I'm now going to get x squared equals 8 minus x squared. So remember that this is that quote-unquote y. Now I can add x squared to both sides because I want to get x by itself. And so now I get 2x squared equals 8 because x squared plus s squared is 2x squared. I can divide both sides by 2. I get x equals 4. Now when we take the square root to both sides, remember, you get that plus or minus. Now that tells me that there are two values for x, both positive 2 and negative 2. So now we need to plug that back in, and we're actually going to plug in both of them. We're going to plug in the positive 2, and we're going to plug in the negative 2. And so if you do that, well, they both equal 4. Because y equals positive 2 squared, 2 times 2 is 4. Y equals negative 2 squared, negative 2 times negative 2 is 4. Now, all you need to do from there is just write them as a point. So I plugged in 2 for x, I get 4 for y. There we go. I plugged in negative 2 for x, I got positive 4 for y. There we go. Now, if I wanted to take a look at this on a graph, as you can see, we found where they intersected. Let's look at another equation here. Now for this one, the variable isn't by itself. So maybe I can get a variable by itself using that top equation. So I just rewrote it, I subtracted x on both sides, and now I get y equals 1 minus x. You could equally do the same thing for x. I could subtract y on both sides, and I get x equals 1 minus y. It would work both ways. But now that I know that y is by itself, I can substitute it into the other equation. And so when I do that, remember this was my y, and so I plugged it in for that y, and I get x squared plus 1 minus x squared equals 13. Now I know your first inclination. Don't do it. You're not distributing that 2. 1 minus x squared means I have two 1 minus x's that are being multiplied. Like that. So now I need to multiply that out. 1 times 1, 1 times negative x times 1, negative x times negative x. And if you do that, you're going to get 1 minus 2x plus x squared. So now, bringing down the x squared, bringing down the 13, I can combine like terms. So x squared plus x squared is 2x squared. Then I have the negative x, and then I have the positive 1 equals 13. Now I'm noticing that this is quadratic. So because it's quadratic, I want it to equal 0. So I'm going to subtract the 13 on both sides. I know there's a 2 in common, so I can factor out the 2, or divide everything by 2. And now I can factor it. So a times c, negative 6, factors of negative 6 that add to negative 1. That's going to be negative 3 and 2. And so, I could break that up into x squared minus 3x plus 2x minus 6. Do the factor by grouping, dot, dot, dot. And you're going to get x minus 3 times x plus 2. Now, because that equals 0, you set each one equal to 0 using the zero product principle. And if you solve for each one, you're going to get x equals 3 and x equals negative 2. Again, 2 answers for x. That's okay. So now we plug them back in. So if I plug in 3, and if I plug in -2, and I'm going to plug them into the top equation, right? So it's x plus y equals 1. So there's my x that I plugged in. There's my x that I plugged in. And now I just need to solve for y in each one. So subtract 3 on both sides. I get y equals -2. Add 2 to both sides. I get y equals 3. And so now I can write my points. When I plugged in 3 for x, I got -2 for y. So there's my first point. When I plugged in -2 for x, I got 3 for y. And so there's my second point. And there's my answer. Now visually, those are the points that we found. So if I put those in a calculator to see what that looks like and see where they intersect, well, we just found those algebraically. So to conclude today's lesson, we learned how to solve a system of nonlinear equations. This does conclude our lesson. If you have any other questions, please leave them in the comments.